Hey there, welcome to the second video in my ongoing series called GameDev Building Blocks, where we take a specific concept from programming and game development in general, and we talk about what it is, um, and then we show some theoretical examples of how it might be useful for you during the process of game development, and then lastly, we'll show an example from a current game that I'm developing. There's two choices to work on, or I also have the source code from a couple other games that I can bust out if I need to. But most of the time, it's probably going to be an example from my own code because that's just kind of what I know the best. So last time we talked about variables and we talked about declaring them, assigning values to them, and we talked about the difference between, var and const. So now what we're going to do is we're going to talk about the types of variables. So recall that we talked about this idea of variables being a container for some information. Well, one thing that the computer is, in your game in general is going to be very curious about is what type of information are you using that variable for. We're going to talk about types just in general, and then we're going to talk about the difference between static types and dynamic types, okay? Because you'll typically hear, oh, that language is a statically typed language, or oh, that language is a dynamically typed language. And sometimes people can get a little weirdly religious about that. It's like, oh, one's better than the other kind of thing. I really don't, I'm not really interested in that. Um, but I will give you the history of typing in the Godot engine because that's what I'm using to teach and build my games in currently. And I think it'll be helpful to kind of understand some of the history about how types evolved in Godot because it will give you an understanding of maybe kind of why things work the way they do. So let's call this types, static versus dynamic. And then we'll just save this. So first of all, what is a static type versus a dynamic type? Well, first of all, we should actually talk about what are types, right? So, for example, maybe you have like a variable called damage. Maybe you set it equal to 10. Maybe you have a variable called enemy name, and that's Lord Montague or something like that. You know, and maybe we have something like uh, maybe we could do like player speed, and maybe that's like 40.5. Okay. So believe it or not, all three of these are actually different types. This is what's considered an integer. This is what's considered a string, and this is what's considered a float. And those are just some of the types in Godot. You can look up the documentation about all the different types. I'll kind of talk about them as they come up. Um, but as you might infer from just the name, the type of a variable kind of tells you something about what type of data you're expected um, to find there, right? So for example, if we know that damage is an integer type, it would make sense for a value like 10 to live in there, right? So one of the things that you have the option of is dynamic type. Your variables can be dynamic typed or they can be statically typed. And if you know what those words dynamic and static mean, you can actually kind of infer what they let you do and what they don't let you do, right? Dynamic typed variables means that they can change, right? So for example, if I have oops, not that callback. I want the ready callback. For example, maybe I'll print damage here. So what we can do is in the ready callback, we can print to console, right? So if we just run this, we can see it prints 10, pretty standard, right? But watch what we can do. We can maybe change damage to maybe, let's say, we'll add 10 more to it, right? And then we'll print it again. So we would expect the first time for it to be 10 and then the next time for it to be 20, right? So let's see here. And indeed we do see that, okay? Well, let's say we do something even more different. We'll set damage equal to a crap ton of damage. Okay, so it'd be interesting if you can kind of guess maybe what might happen here. And actually, let's see, I forgot to print damage the third time. So let me do that again here. And notice that it printed a crap ton of damage. So we were able to change from 10, 20 to string. Now, this is what a dynamically typed variable lets you do. Basically, this variable used to be an integer, and then it got changed to a string. So I can kind of show that to you too. All right, sorry about that. I'm back. I had to look up its type of is the name of the function. And what that will do is that will return the internal type of the given variable, okay? So what we're going to do is we're going to print the type. How about this? We'll print damage, and then we'll print its type, and then we'll print it again after we changed it, and then we will print type of, and then damage. So just to clarify, type of is a built-in kind of global function that you can use where you can pass in any variable and it will tell you the type. So if we look at this here, now this might be a little confusing because notice that it says the type is 2 and the type is 4, right? Well, these are actually kind of codes for specific types in Godot. Okay, so this might be a little tricky if you don't know this information, but again, that's why I'm making these videos, just to try to kind of get that information out there. Just from kind of from trial and error, like I know that 2 represents an integer type and 4 represents a string. And I was trying to find a way to know that, and basically if you go to the documentation and you see the basic built-in types, if you start counting from 0, it lines up. So 0 is null, 1 is a bool, 2 is an int, 3 is a float, and 4 is a string, right? So, but the important thing, I don't want to get too lost in the details here. The important thing is that this single variable was able to change its type because it's a dynamically typed variable, okay? Now, if you come from a dynamically typed programming language like maybe Python or something like that, you'll feel really at home with this. But let's talk about static typed. So again, static type, as it would imply, basically means that the variable can't change. So if I specifically say that basically what I'm telling Godot is that this variable is now a statically typed variable of type integer. And notice that what happens here is this cannot assign a value of type string as int. So I used to be able to do this, but now I can't, right? And similar to the discussion we had last video about const versus var, your instinct may be, ooh, I don't like this. Like I like having more options, you know. But I'm going to make the case to statically type your variables in your projects because it does give you some additional features that help you in the context of developing a video game. So one of those things is that, you know, by the time your game grows, your code base can get quite complex. And sometimes you can introduce all sorts of weird bugs or unexpected things when the types of variables start changing out from under you, right? Because maybe you're doing an operation somewhere in your code where you're assuming that damage is always an integer, right? Maybe you're like adding something to it, right? Well, if sometimes it's an integer and sometimes it's a string, you can't really count on it, right? It's not consistent. So that's kind of what statically typed variables are. Now, how to do them in GDScript, there are basically 2 ways. Okay, so the first is to what's called explicitly statically type the variable, where after you declare the variable name, you put a colon, and then you put the type here, okay, equals 10, okay? So if I wanted to, statically type this to a string, I would do that. And if I wanted to statically type this to a float, I would do that, okay? So that's how I would do that. But there's another way to do it. And you'll see this in a lot of different applications, is you'll see this kind of colon equals. And one of the questions that I get a lot from people when they're first starting is like, what's the difference between, doing equals or colon equals, right? Because it's subtle. It's only one little difference, right? Well, basically what we're doing is we're saving us the trouble of doing this. We're basically letting Godot figure it out. What we're essentially saying is, remember how I was saying this is basically explicitly statically typing? Doing something like this is what's called implicitly statically typing, where you're inferring the type, okay? So basically what you're doing is you're saying, hey, Godot, you see that thing? That's a number 10. That's obviously an integer, right? So can you just make sure that this is statically typed to an integer for me? I don't really want to like type out the word integer. You know what I mean? So that's kind of what that's doing. And there are some pros and cons. I would say one of the pros to doing it this way is that it's really like human readable, right? It's like there's no question this variable is an integer, like it has to be. You know what I mean? Whereas with this, you have to look at that value there and go, oh, that's an integer. I'm inferring the type here, so therefore this variable is statically typed to an integer, right? So there are two different ways of doing it, but ultimately once that variable is statically typed to an integer, it operates the same, right? One of the benefits to doing it this way is when you let Godot infer the types, there is an argument to be made for making less mistakes. You don't end up doing things like, let's say, for example, you do, I'm just trying to think of another like jump height. And let's say you do float, but then you do like that. This is a little ambiguous, right? Because floats usually have a decimal. So like here, I'll show you. So if we print type of, and then we'll do jump height. Okay. So I want you to guess what, now knowing that I think float was number 3, I want you and float was 3 and integer was 2, predict what type GDScript is going to say this is. It's going to say it's a float, right? Because we explicitly declared it to be a float, right? But watch what happens if we infer it, okay? If we infer it, we actually get a type 2, right? And that's because technically speaking, if you want to write 100 as a float, you need to put at least 1 decimal 0 after that, right? Because a float, remember, implies a decimal part of a number. So what Godot's doing here by inferring the type is actually helping us out a little bit, because it's actually making us notice that now it is a number 3, which is a float. It's actually helping us out because it's forcing us to be a little bit more clear with our values that we assign, basically. So you'll see me tend to do, well, I tend to do both, honestly. It kind of depends, Now there are some times where you have to explicitly declare. So for example, let's say you have like health, and it's going to be an integer, but you just don't know what it's going to be yet, right? So what you can do is, oh, I cannot assign a value of type null as int. Yeah, that's right. But I think I can do this. Yeah. So you can do this where you're basically saying, hey, I know health is supposed to be an integer, but I don't really feel like giving it a default value because I'm not really sure what it's going to be yet. So here you have to explicitly state the type if you want to statically type it, because if you just do this, then, I mean, basically all you've done here is you have a dynamically typed variable named health. But by doing this, we don't have a value on the right side of an equal sign in order to infer the type. So this is basically saying, hey, make that a a integer, but I don't know what value it's going to be yet. Okay. Hopefully this is making sense. So that's kind of the boring stuff. That's kind of what static typing versus dynamic typing is, and that's how to accomplish it in GDScript. So now let's actually talk about some theoretical applications of this. Well, to be honest, it's not that hard to think of one. Here's a situation where static typing really saves the day, right? So let's say, for example, I statically type damage to 100, right? So basically, damage is always going to be an integer, right? And let's say someone else is working, and basically there are systems of the game further downstream, like UI systems, damage calculation systems, like all these things that are built on the assumption that damage is always an integer, okay? But let's say that a colleague is working on a new boss and they are balancing the damage and they say, oh, the damage should increase by maybe 10 and a half. You know what I mean? So notice that it's actually not giving me an error here, but it might when I actually run it. Oh, if I try to print damage here. So we actually get 110, right? So that's a little bit unfortunate, right? Because the person who's tuning the boss thinks that the damage value is going to be 110.5, but because this is explicitly statically typed to be an integer, I can't add 10.5 to it without rounding it, basically. What we could do here, I was kind of actually expecting it to print a warning. Yeah, it does here. See, it says narrowing conversion, right? So this time it didn't necessarily yell at me. In a stricter typed language, it would. Something like C or something like that, you wouldn't get away with this. But see, it says narrowing conversion. Float is converted to int and loses precision. Well, that's a good warning for my colleague to know, right? Because then my colleague can go, oh, shoot, you know what? That's supposed to be an int. Oh, I shouldn't be adding decimals to it. I'll add, integers to it, right? So, but notice what would have happened is if we had just dynamically typed it, then there's no problem adding 10.5 to a dynamically typed version of this variable, because if we run this, we can see we get 110.5. And on the surface, that might seem like a good thing, right? Like that's nice and flexible, right? But I would argue that, remember what I said about those downstream systems, right? Those downstream systems are not expecting to get a float, something with a decimal, right? So all of a sudden, your game is freaking out downstream. All your systems are starting to kind of go on the fritz, all because someone was trying to balance a boss and they thought, oh, you know what? They're doing a little 10's not enough damage, 11's too much. I'll split the difference 10.5, right? That's a very innocent decision that someone could make, and it could cause all sorts of kind of problems, right? So that's kind of a theoretical example of where static typing kind of saves your butt a little bit. But by all means, if you like dynamic types, if that's kind of the paradigm that you come from, by all means, feel free to use it. I'm just presenting, some findings that I found where, again, as I said in episode 1, some of these issues don't rear themselves until you get really far into production and your game starts to grow in scope, right? And there were some things that happened when I reached that, where I was like, boy, I really wish I knew these things. And that's really the main point of this game dev building block series. Is it's not really meant for folks who are just doing like Flappy Bird. You know what I mean? Like if you are doing Flappy Bird, then I'm really glad you're here. But where I'm really gearing this series towards is maybe folks that have a game that they have in the back of their mind that they want to build, and it's going to be a little bit more complex, right? It's going to be a heavier code base. And so I'm trying to kind of get you, forewarned is forearmed, right? Trying to kind of share with you some of the things that I've learned along the way so that you will end up in a better place after, months of development than I was on certain projects. Okay. So that being said, let's go take a look at where we are utilizing this in an actual game. All right, well, here we are deep in the heart of the source code of the Brute Squad, the last roundup. And I found a specific instance where I think it will demonstrate why I chose to go with static typing a lot of the time. So it's an RPG, so basically the attacks are all descendants of this class called combat action, right? And we'll get into this, more and more as the series goes on. But essentially, the point of having a class like this is that we can basically create some functionality that all combat actions kind of share, right? And so notice that the resource cost is statically typed to an integer, right? And it actually defaults to 0. But the point is that if we get into the game, and we get into combat here, or actually, yeah, I'll pick up an item just so I don't die. I guess I'll put my mini in the front here. Okay. So, sorry, I'm gonna just blast through combat here. Or I'm gonna attempt to blast through combat. I guess I can explain a little bit about the game as we're playing it. I kind of want. Actually, I'll talk more about the game. Now, I'm just trying to decide if I want to do it in the devlog or not, or in the video. Let me actually do this. Let me restart. And I'll just turn the music down a little bit so that you guys can hear me. Alright, we spawned 1,000,000 treasure chests, but we won't cheat. We'll just take one item here. Oh, you know what? Couldn't hurt to have another. Oh, we got some good plate items here. I guess I'll just I'll lead with my mini. We'll try this again. But basically, the basic mechanics of this game is that it's 3-on-3 combat, and you have a point character and you have 2 assist characters, right? And the way it works is that the assist characters always go first, but everyone has a different speed attribute. So what will happen is the 4 assist characters, at the beginning of a combat, the 4 assist characters the game will look at all of their speeds and then order them, right? So our little grass mage girl is the fastest, followed by our blonde-haired barbarian, and then this person is the next fastest, and then this one is the 4th fastest. And then the point characters will take their turns, and that is another speed check. So by looking at the top, you can see the order that the combatants will go in, and you can see whose turn it is. So I'm going to use an assist. This is actually a pretty bad matchup for me. So I'm going to use Hello Gabna, which is a snowball attack, and it's the only move in the game that has a built-in switch out. So because this is water, I'm going to switch to my grass type to try to take it. Yeah, so there we go. We predicted the water attack, and we were able to take it pretty good there. The only problem is I don't think my grass mage has very many attacks right now at level 1. Okay, we do have Mad Cat Blast, which is a kind of poison attack. Oh, this is going to be tough. This might actually kill her. Yeah. Unfortunately, that was a typing disadvantage there for super effective. So now I've got a little bit of a decision to make because this guy's really tanky. I just know that about that enemy type. Just gonna look at the debugger here. Okay, so yeah, those are I know about those errors. So on the one hand, he is poisoned, so I just need to outlast him. But my fire type is gonna get absolutely destroyed by the water. So I'll bring in my water mage. It's just that my water mage is kind of squishy. So yeah, let's just try to attack here. Okay, he took the hit. That's good. So I think one more. I'm not sure, but maybe I'm gonna try to switch out here with the snowball. Okay, I didn't kill him, but I can switch out. Oh no! Okay, so even though that was a water attack versus fire, because I looted that good pantaloons for this guy, he's actually pretty beefed up. So just kind of giving you like a flavor for the game, and then where the resource comes in, I will show you guys. Okay, so here, so now at the loot screen, we have the ability to choose a move. Oh, we got a rare. Okay, so we got one rare and 2 commons, and basically this resource up here is how much mana it costs to use these assists. Okay, so this is an example where, because we've statically typed resource cost to integer, we know that there's going to be no funny business in terms of like an assist costing like 3.5 resources. You know, that's just not, our game's system isn't built to handle that, right? It's balanced, and it's meant to be you can click on the cards, by the way, to look at the back and read about what the moves do. There's kind of like I guess I'll just go over this. So there's a brief description here, the type of the move, and then this tells you whether or not it's an assist or a point attack. So the combatants can only use point attacks when they're in the point slot, and only use assist attacks when they're in the assist slot, right? But back to my original point, because resource is an integer, we have a very solid, confidence going forward, knowing that our combat actions will always cost, either 3 or 2 or 1, and it won't be something weird like 2.5, right? Which could potentially cause our game to crash. I'm gonna grab the rare version of She Slimed Me, and we'll see. Our party's looking pretty bad right now. This guy's KO'd. Our only chance is to probably pick up another item here. Yeah, we're just gonna go all in on this guy. Ooh. Well, you know what? Sorry. I'll go ahead and stop here. But I will say, I've put hundreds of hours in testing this game, and the fact that I still want to keep playing and I just want like one more combat, I think that's, if you find yourself at that point while you're developing, it should put a smile on your face, because that is a sign that you're onto something that is at least something that you want to see in the world, right? So I think sometimes it's easy to get wrapped up in, oh, what video game genre is hot or trending or things like that. And, you're free to chase that. That's definitely something that people do. But I think that where it becomes the most fun is you think about, what is the game that I want to play right now that is currently not available, and make that game, right? That's what That's what I do. That's what my brothers and I do, and it's really been a blast. So anyway, thank you very much for tuning in. This is the end of episode 2. We learned about dynamic versus static typed variables. We saw how static typing can give us a little bit of protection against things maybe being maybe some undefined behavior down the road. And we saw how we used our static typing in our code base for our RPG to give us peace of mind, knowing that things aren't just going to change types out from under us. All right, I hope you enjoyed it. I know I did. I love talking about this stuff. So thank you for hanging out with me, and we'll see you in the next one.